So Chris, I see a new box has entered the arena here. This is your, what, GZ1062 function generator?
The DG1062Z, yep.
Excellent. So we have this set up right now to do a sweep, right?
Yeah, we're going to be sweeping between 1 and 10 megahertz about once a second and do a little analysis on that to check out our scope.
Fantastic. Okay, are you set up on your end?
I think I about am.
And I have to push this one whole button?
Yeah, go ahead and turn that on.
Fantastic.
So,
okay.
so now we can see our sweeping signal there. So what we're doing is, again, just a sine wave at about a megahertz sweeping up in about once a second. Now what's interesting with the scope is we can go ahead and do what we call a record on this. So what we're going to do actually is record 1,000 frames over about 5 seconds. And now that it's done, we're going to go into the utility menu here, in the record menu, and go ahead and make this go into what we call analyze mode. Mm-hmm. So this is going to allow us to do some really neat sort of front panel analysis on this, on this scope. So in trace mode, what we can do is we can set this template, and what it's going to do is from that first capture it took, it's going to look at how different each of the following frames are.
Okay.
And then we're going to get a nice comparison about how that looks and what that happens. So it's actually doing sort of RMS error data on a point-by-point basis across thousands of frames and really thousands of data points per frame.
Wow.
So it's going to do millions of RMS calculations for us here, and it's about 3/4 of the way through. So
no kidding, already on 1,000 frames.
We're almost done. So yeah, so that's going to be pretty neat at the end here. So in this case, I think a little later we're going to show the pass-fail mask, which is a little more discrete. But this is in a kind of earlier debug phase when you're not sure what's going on and you're trying to find the source of a problem. You can really get some interesting data out of these kind of periodic kind of signal analysis challenges. Oh, here you go. So if you look at the bottom here, Laura, you'll see this nice color bar going from sort of green to blue.
Yes, okay.
And so what that's really indicating here is, and there's a histogram as well, how different each one is.
Yeah.
And so that shows you that sort of periodicity. So we took 1,000 samples over about 5 seconds.
Yep.
And because the wave is going about, it was sweeping about once a second, we really see sort of 5 periodic blips across the screen, evenly spaced. So if you were looking at a power supply, or you're looking at a signal coming off one of your ICs, and it was giving you trouble like this, you could say, oh, is that 60 hertz noise that's coming through?
Right.
Is it something that might be related to some EMI coming from some other part on the chip, or a clock that's too close, an oscillator? And you can say, all right, so I see the period of that, even though I couldn't capture it all in one wave. And now I can look deeper for what the real problem is.
That's really interesting. Okay, and you captured 1,000 frames. You can do a lot more than that, can't you?
Yeah, this instrument can capture tens of thousands. I think at least 32,000 frames in its normal mode. It's all kind of depending on the memory depth you want, the time base.
Yeah, and that is something I see you guys really strong in. A lot of memory in these devices.
Yeah, it's great.
Fantastic.
Same story is really true on the generator. So that guy has 8 million points of memory standard. So if you wanted to put an arbitrary wave through this, you could make a wave of your own with 8 million different points in it and push it out to the scope to do analysis.
Okay, fantastic.
Yep.